Good day, everyone. For today, we will continue our discussion about vectors. For today's topic, we will be having product of vectors or multiplication of vectors. Here are the example of formula that used the multiplication of vectors. We have work is equal to the dot product of force and displacement. Torque, which is equal to the cross product of the lever arm and force. And we have here electric force as the product of charge times velocity multiplied using magnetic field. So this formula were actually the applications of the multiplication of vectors. So many physical relationships in physics can be expressed by using product or multiplication of vectors, and these are the examples. And if we are multiplying vectors, we can actually use two, either the dot product, also called as the scalar product, and the cross product, also called as the vector product. So for today, we will focus our discussion with these two kinds of the multiplication of vectors. So let's start with the scalar product, also called as dot product. So what is a scalar or a dot product? So dot product, we will define it as the magnitude of A multiplied by the component of B that is parallel to A. For us to understand more, let's use our illustration. So we have here two given vectors, vector A and vector B. Our vector B here has a direction which is phi with respect to A. So if we are trying to get the dot product of A and B or A dot B, we must multiply the magnitude of A to the component of B that is parallel to A. So having this illustration, if we will try to analyze the picture, this is the component of B that is parallel to our A, or this is the x component of B that is parallel to A. Because our A is in the x direction or x-axis, therefore, we will multiply the x component of B that is also in the same direction as A. So this x component of B can be calculated as B cosine phi. Or we can also multiply the magnitude of B times the component of A that is parallel to B. And the component of A that is parallel to B is this side or this portion, which is A cosine phi. So having the definition of the dot product, we have the general formula for the dot product as A dot B is equal to the magnitude of A times the magnitude of B times cosine phi. And this angle is the angle between A and B. So if we will try to get the scalar product or the dot product of two vectors that are perpendicular to each other, there will always be an answer of 0. So example is, if you will look at the illustration, vector along x-axis and vector along y-axis or I hat and j hat, they are perpendicular to each other. Therefore, if we will multiply I dot j, the answer will be 0. So again, if we are multiplying using dot product, the two vectors that are perpendicular to each other, they will have a result that is always 0. So if we will follow the general formula, I dot j is equal to the magnitude of I, which is 1, times the magnitude of j, which is also 1, times cosine angle. And this angle is the angle between I and j, which is 90 degrees. So calculating this, it will give us a result of 0. Same also goes with the other vectors that are perpendicular to each other, such as we have I dot k. As you can see, I and k are also 90 degrees to each other. So therefore, I dot k will also give a result of 0. We also have j dot k. And j dot k are also perpendicular to each other, and therefore the result will also be 0. So therefore, if we are using scalar or dot product, we can multiply only vectors that are not perpendicular to each other. So example is I dot I. So I dot I is equal to 1, which is the magnitude of I, times 1, which is the magnitude of I, times cosine 0 degree. So 0 degree or 180 degree. It will give us a result of 1. Same goes with j dot j is equal to 1 and k dot k is equal to 1. So what you can observe here, we can have a result if we are multiplying the same vectors having the same direction. But if we are multiplying vectors having different direction or perpendicular to each other, the result will be 0. So this is our example. So if we are given two vectors, A and vector B, wherein they are written using the rectangular form of a vector. So our vector A is A sub x I hat plus A sub y j hat plus A sub z k hat. And our vector B is B sub x I hat plus B sub y j hat plus B sub z k hat. If we are asked to get the product of A and B using that product, or A dot B, it will be the vector A dot vector B. And for us to get the dot product, we will only multiply like components. And we have to add it. So therefore, when we say like components, that means A sub x times B sub x plus A sub y times B sub y plus A sub z times B sub z. So this is how to multiply using a scalar product or dot product. We will multiply only those having like components and then we have to add. And it is also called a scalar product because the product here does not have any direction. So the product here will be a scalar one. No direction, it's only with magnitude. So let's have the example. So we have here three given vectors. Vector A as 8i hat plus 4j hat minus 2k hat Newton. Vector B, 2j hat plus 6k hat meter. And vector C, 3i hat minus 2j hat plus 4k hat meter. We are asked to calculate the following. Number 1, A dot B. Number 2, the angle between vectors A and B. Number 3, the orthogonal component of vector B in the direction of C. In our first problem, we are asked to look for the dot product of A and B. For the solution, A dot B is equal to 8i hat plus 4j hat minus 2k hat Newton dot 2j hat plus 6k hat meter. So again, if we are multiplying using a dot product or scalar product, we can only multiply having the same components. That means a 8I hat must be multiplied to the same component of b, which is 0 because there is no I hat here. 4j hat must be multiplied to 2j hat, and negative 2k hat must be multiplied to 6k hat. And this will give us 8I hat times 0I hat plus 4j hat times 2j hat plus negative 2k hat times 6k hat Newton meter. To simplify this, we have 8 times 0 is 0 plus 4 times 2 is 8 plus negative 2 times 6 is negative 12. Unit is Newton dot meter. I hat dot I hat, the answer is 1. That is why we don't indicate here 0 I hat. J hat times dot j hat, the answer is also 1. That's why it's only 8 and we don't indicate j hat. And k hat dot k hat, the answer is also 1. That is why we don't indicate k hat. So simplifying this will give us an answer of negative 4 Newton dot meter. So again, A dot B will have an answer of negative 4 Newton dot meter, which is a scalar quantity. So we don't have any direction for the dot product, only the magnitude. So these are the second and the third unknown in our problem. We are asked to calculate for the angle, and we are also asked to calculate for the orthogonal component of one vector. So how can we get the angle between the two vectors using dot product? So again, we are given vectors A and B based on the illustration. And the angle between A and B is theta. So using again the general formula or definition for our dot product, A dot B means the magnitude of A multiplied to the magnitude of B times cosine theta. And the angle is the angle between the two vectors. Deriving our formula for the angle, we will have cosine angle is equal to A dot B divided by the magnitude of A times the magnitude of B. We got the second line of equation from the first equation given. We can also rewrite our formula as vector A divided by magnitude of A dot vector B divided by magnitude of B. Or we can also rewrite this using our lambda sign. So this lambda is the unit vector of A. So cosine theta is equal to lambda A dot lambda B, or unit vector A dot unit vector B. So when we say unit vector or lambda, we are referring to the vector A divided by the magnitude of A. And for our orthogonal component of a vector in a given direction, again, using our general definition for the dot product, which is magnitude of A times the magnitude of B times cosine theta, we can derive the equation here for our orthogonal component. So the orthogonal component is the B cosine theta. So this orthogonal component or B cosine theta is equal to A dot B divided by the magnitude of A. So this equation here was derived from the general equation of our dot product. Rewriting our formula, the orthogonal component of B, which is the B cosine theta, is equal to our vector B times the unit vector for A, or lambda A. So let's go back to our example problem 1. So for our example problem 1, we are asked to calculate for the angle between vectors A and B. So again, using our general equation for the dot product, so when we say A dot B, that means the magnitude of A times the magnitude of B cosine theta. And this theta is the angle between A and B. So we are looking for the value of this theta. So out of this equation, we can derive that cosine theta is equal to the dot product of A and B divided by the magnitude of A multiplied by the magnitude of B. Based on our previous solution, we got this answer already as A dot B is equal to negative 4 Newton dot meter. So again, A dot B, which is negative 4 Newton dot meter, this was the answer from our previous problem. So what we have to calculate now is the magnitude of A and the magnitude of B. So for the magnitude of A, we can get it using the square root of the sum of the squared of each components. So that is the square root of 8 squared plus 4 squared plus negative 2 squared. The unit is Newton and we also have to square it. Using your calculator, and to simplify this, we have the magnitude of A is equal to the square root of 84 Newton. Let's now compute for the magnitude of B. For the magnitude of B, that is the same as the square root of the sum of the squared of each component. So, it is the square root of 2 squared plus 6 squared. The unit is meter squared. Simplifying this using the calculator, we have for the magnitude of B as the square root of 40 meters. We can now substitute the value of A dot B, the magnitude of A, and the magnitude of B in our equation. So that is for our angle is equal to, we have to get the inverse cosine. So inverse cosine of A dot B, which is negative 4 Newton dot meter, divided by the magnitude of A, which is square root of 84 Newton, multiplied by the magnitude of B, which is square root of 40 meter. Computing this using the calculator, you will have the answer as angle is equal to 93.96 degree. And this will be our final answer. So 93.96 degree is the angle between vectors A and B. For the last unknown, that is to find the orthogonal component of vector B in the direction of C. So therefore, the vectors involved are B and C. Therefore, we will use the formula for the dot product of B and C, and that is B dot C is equal to the magnitude of B multiplied by the magnitude of C times cosine theta. And the orthogonal component is the b cosine theta. So, b cosine theta is equal to b dot c divided by magnitude of c. So, this equation, we got it from the general equation of the dot product. So, we have to know what is b dot c and the magnitude of c. So, let's start with the dot product of b and c. So, for our dot product of b and c, that is 0 I hat dot 3 I hat. So 0 because for our vector b, there is no x component here. So it means 0 I hat plus 2j hat dot negative 2j hat plus 6k hat dot 4k hat. The unit is meter squared. Simplify b dot c, we will have 0 times 3 is 0 plus 2 times negative 2 is negative 4 plus 6 times 4 is 24. So for our b dot c, it is equivalent to 20 meters squared. Let's now proceed with the magnitude of c. For the magnitude of c, we have to get the square root of the sum of the squared of each components. So that is the square root of 3 squared plus negative 2 squared plus 4 squared meter squared. Simplifying the magnitude of c, we will have square root of 29 meter. So we can now substitute the value of b dot c and the magnitude of c in our equation to get the orthogonal component of b. So for the orthogonal component or b cosine theta, we have b dot c is 20 meters squared and magnitude of c is square root of 29 meter. Using your calculator, you can compute 420 divided by square root of 29 as 3.71. The unit is meter. So this is our final answer for the orthogonal component of b in the direction of c. Another kind of multiplication of vector is the vector product, also known as cross product. So cross product will use a symbol of cross sign. To define what is a cross product, we are given two vectors a and b. So when we say a cross b, that is equal to the vector product with a direction that is perpendicular to both planes of A and B. So meaning the product of A and B is a vector that is always perpendicular to A and also perpendicular to B. Using an equation form, A cross B is the same as the magnitude of A times the magnitude of B times sine phi. So our angle here is the angle between vectors A and B. So the vector product of any vector with itself is 0. So an example is I cross I. So I is being multiplied to itself and the answer will always be 0 because I cross I means magnitude of I is 1 times the magnitude of I is 1 times sine angle, and this 0 degree here is the angle between I and I. So 1 times 1 times sine 0 is 0. Same with J cross J and K cross K. So remember, if you are multiplying vector to itself using a cross product, the answer will always be 0. But if we will multiply vector with another vector in the different direction, we will have an answer that is not 0. So example is I cross j. The answer is k. So what can you observe here? Our answer here, or the product itself, has a direction. That is why it is called as a vector product, because the product will have a magnitude and direction. J cross k is equal to I, and k cross I is equal to j. However, if we will change the position of the vectors being multiplied, such as I cross j will now be j cross I, it will give a negative answer, which is negative k. K cross j will give us negative I, and I cross k will give us negative j. So again, if you are multiplying vectors using a cross product, it is very important to take note of the positions of the vectors being multiplied. If you change the position of the vectors being multiplied, it will give you a different answer. So k cross I is not the same as I cross k because they have different direction. That is because of the right hand rule. So in our right hand rule, there are always two directions perpendicular to a given plane, one on each side of the plane. So as you can see here, using a right hand, A cross B will give us a vector that is, or that has a direction upward, while B cross A will give us an answer that has a direction of downward. The vector product or the cross product can also be expressed using the determinant of a matrix. So example is, we are asked to multiply A cross B. So write it in a matrix form for us to easily multiply using vector product. So this is the matrix form of A cross B. So write the components of A, that those are A sub x, A sub y, and A sub z, and the components of B as B sub x, B sub y, and B sub z. So let us multiply first J cross K. So J cross K, remember, will give us an answer which is I. So therefore, A cross B is equal to, so multiply J cross K, which is A sub y times B sub z. The direction is I. While K cross J is negative I. So that is why minus A sub z times B sub y. Direction is I. Plus, let's multiply K cross I. So K cross I will have an answer which is J. So plus A sub z, B sub x, J hat, minus I cross K, which is A sub x times B sub z, J hat. And our last is I cross J, which will give an answer of K. So plus A sub x, B sub y, K hat, minus A sub y, B sub x, K hat. Let us combine the terms having the same direction. So that is A sub y, B sub z, minus A sub z, B sub y, I hat, plus A sub x, A sub z rather, times B sub x, minus A sub x, B sub z, J hat, plus a sub x b sub y minus a sub y b sub x k hat. So this is how you will multiply two vectors using a cross product in the matrix form. Let's apply this in our given example. So in our example, we are given vectors A, B, and C. We are asked to calculate for the cross product of A and B, or A cross B. So for the solution, let us write first vectors A and B in a matrix form. So we have the components of A as positive 8, positive 4, and negative 2. And for B, we don't have x component, that is why 0. We have positive 2 and positive 6. So let's start now multiplying the vectors or the components. Those are, let's start with J cross K. So that is 4 times 6 minus negative 2 times 2. Direction is I hat. Plus, let's multiply K cross I and I cross K. So plus negative 2 times 0 minus 8 times 6. Direction is J hat. And the last is I cross J and J cross I. So I cross J is 8 times 2. J cross I is minus 4 times 0. The direction is K hat. Simplifying this, we will have 4 times 6 minus negative 2 times 2 is 24 plus 4 I hat. For the J hat, we have 0 minus 48. And for the last term, we have here plus 16 minus 0 K hat. And the unit is Newton times meter. So 24 plus 4 is 28. 0 minus 48 is negative 48. 16 minus 0 is positive 16. So for our final answer, the cross product of A and B, or A cross B, is equal to 28I hat minus 48J hat plus 16K hat. The unit is Newton times meter. So again, remember, if we are multiplying vectors using a cross product, we will have an answer that is also a vector. Therefore, there is a magnitude and there is the direction.